Hello and welcome to today's lesson on kinetic energy. In this lesson, we will understand that kinetic energy is the energy of motion and explore how the speed and mass of an object affects its kinetic energy. We will also apply our understanding of kinetic energy to various real-life scenarios. Finally, we will briefly discuss two common misconceptions about kinetic energy, which you should avoid in your exams. So far, you have learned that energy can neither be created nor destroyed, but can be converted from one form to another. We have also learned about chemical energy as a key energy form. Building on this foundation, we can now delve into kinetic energy. Recognizing kinetic energy in various scenarios will enhance our comprehension of how energy operates in the world around us. Kinetic energy is the energy that an object possesses due to its motion. Whenever an object is moving, it has kinetic energy. This means that anything from a rolling ball to a speeding car has kinetic energy. The amount of kinetic energy an object has depends on two key factors, mass and speed. The first factor which affects kinetic energy is mass. Mass is the amount of matter in an object. Heavier objects have more mass. For a given speed, a heavier object has more kinetic energy than a lighter one. For example, a truck moving at the same speed as a car will have more kinetic energy because the truck has a greater mass. This is because more energy is required to move a heavier object at the same speed. The second factor which affects kinetic energy is speed. Speed refers to how fast an object is moving. The faster an object moves, the greater its kinetic energy. This means if you throw a ball harder, making it travel faster, it will have more kinetic energy compared to the same ball thrown softly at a slower speed. Let's now examine some examples where kinetic energy is involved. One of the most common examples of kinetic energy is a moving vehicle. Whether it's a car, bicycle, or train, as long as it is in motion, it possesses kinetic energy. The faster the vehicle moves, the greater its kinetic energy. Let's take the example of a car. When the car speeds up, the engine converts chemical energy from fuel into the kinetic energy that propels the car forward. Another example is throwing a ball. When you throw a ball, the chemical energy stored in your muscles is converted into the kinetic energy of your arm, and then finally into the kinetic energy of the ball, sending it flying. The faster you throw it, the more kinetic energy it will have. Wind turbines harness kinetic energy from the wind. As the wind blows, it transfers kinetic energy to the turbine blades, causing them to spin. This kinetic energy is then converted into electrical energy through a generator. The stronger the wind, the more kinetic energy is available to be converted into electricity. Before we round off, let us clarify a few misconceptions about kinetic energy. The first misconception is that an object at rest has kinetic energy. This is not true. An object at rest has no kinetic energy. It's important to remember that kinetic energy is solely a property of moving objects. The second misconception is that energy can be destroyed. This is also false. When a moving object slows down, its kinetic energy decreases because some of it may be converted into other forms of energy, such as heat due to friction. As always, energy is conserved. Great work, that's the end of our lesson today. Let's recap. First, we delved into the concept of kinetic energy and its significance in the field of physics. We defined kinetic energy as the energy an object possesses due to its motion, dependent on both mass and speed. We looked at various examples where kinetic energy is evident, such as a moving vehicle, a flying ball, and a rotating wind turbine. These examples helped us understand how kinetic energy applies to real-world scenarios. Understanding kinetic energy is crucial as it forms the foundation for more advanced topics in energy and motion.